Welcome to a new test and teardown video. This time I got a Bruker BFX-5. I think this is a German company. I'm not super sure, but it sounds German to me, this name. But I will of course go and double check this. I could not Google anything about this BFX-5. But the company name and logo was easy to find. They still got a web page and they sell and manufacture all sorts of medical, technical instruments. So maybe this was more of what they did back in the old days. So I believe this is an RF amplifier. And I think it's quite clear. We got the RF output N connector. We got some RF inputs B and C connectors. So this tells me a little bit about the frequency range. Other than that, I haven't yet figured out anything about frequency. Here we got the 5 watts of output power. And so there's a variable power. A lamp that says 28 volts, okay. And everything is on the front. Mains and mains voltage selector and the mains fuse, everything is on the front. So this is like the old 60s and 70s style, right? But how old is this thing? I don't know. I really don't know yet. Inside it's very traditional. Mains transformer, some mains stuff. There's probably the little NCC for inrush. Got a lot of rectifiers and capacitors and all that kind of stuff. And there's also a high voltage section with some 450 volt capacitors. More fuses and more goody stuff. And the power supply here with high power regulators. And I was able to check out the date codes on some of them in there. And that's 1987. So far, so good, right? So this box here is connected to the power adjust. I guess that is the power adjust. This one goes to the potentiometer right there. You see the color of that wire. So overload is that one, and then 15 volts of DC. We got some low power inputs, and then this is the RF output. So this is a pre-amplifier with variable gain. And this one goes, of course, into the high power amplifier, if you can call a 5 watt stage that. There's also an input here. And this is, of course, a high power input. And this is just connected to one of the B and C connectors in the front. And then there is the low power input from the power amplifier. Variable, right? So you can go this way or that way. So there's probably a little combiner in here or something like that. We got this power meter right here with 2 little chips that drives all those LEDs. There's one little DC wire for supply, and then there is also another signal that just goes to the forward output. So there's a little detector in there. And there's some other input. So look at this, the voltages. 15 volt positive, okay? And -5, +5. And what is that? So another supply, 400 volts. Say what? Why are we having 400 volts into a power amplifier like this? Is this tube based? I mean, it's really, look at that with my fingers. It's only 2.5 centimeters or something like that. That is really funny. I said it's 2.5 centimeters. Is that what I said? Oh, that's interesting. So I think we should definitely open the power amplifier first. So that was all the screws. I didn't even open the lid yet because I think we should do this together. It's gonna be more fun that way, right? So what is in here? A what? What the heck is going on here? I did not expect any of that. So this is output. And what the heck is this thingy? I've never in my life seen anything like this before. So this is a 400. Where's the 400 volts? What is the idea? So 400 volt goes here and then becomes some funky stuff. I don't know. So this is supply voltage, right? What is this component? Aha. So this input here goes to this one. So we've got 2 inputs. It's getting weirder and weirder. Oh, there's a pre-amplifier here. So this is our low and a ton of gain, and it becomes all this. This I can look up, the MRF137, and this is also from 87. Okay, so far so good, but what is this one? I've been playing a little bit more with this unit and measuring around, and so far I already figured out what is going on here. So this is the mystery part that I didn't really figure out what was in the first second. You got 5 pins, the RF inputs and the output, right? Obviously, it's a diode switch, an integrated special RF diode switch. Really interesting. And you see all the inductors around it, inductors and capacitors to handle all its fantastic features. What I think is really, really interesting, that is the 400 volt drive voltage, which is of course missing. I will of course put in a nice little picture here that shows the way that I measured the diodes in this RF switch. And you can also see there's a high power RF input here. And then you can select this. This one is from the front B and C connectors. And then when this is selected, it of course goes directly to the output. And then it's the other input that comes from the RF power stage and the power driver. And this is a high power VHF transistor capable of 30 watts. But I bet with the gain and all that, it's about 5 to 7 watts. So that matches about what we see on the front. Here is a front stage amplifier. It handles about 1 milliwatts into 0.7 watts. And we got a little attenuator or some match right here. And the 0.7 watts of outputs here goes into this stage right there. This is a field effect transistor. And the field effect transistor biasing is this wire right there, right? And bias, I think the way that bias works, this IC is probably a high power buffer or amplifier, op amp or something like that. I can't look this part up, which is a little bit annoying. I don't know exactly how to do that. And that will be the bias potentiometer. We got another input that is also one of the front B and C connectors. And I bet that is amplified as well, probably driving. Also bias enable. and it's probably also enabling the switching system here. So all this switching system here with the 400 volts and all that kind of stuff is probably handling the two diode switches so that one goes positive in enabling the signal path and the other one is disabling the other one with a huge potential voltage for a good isolation. I'm not super sure what exactly goes on here, but I think that is more or less something like that, right? So the missing 400 volts, I measure it to be 300 and something, was due to a blown fuse in that high voltage section. You see those two wires here, goes of course directly to the high voltage inputs right there. So there's a plus volt and then the plus 400 as the label said, and that will be the high voltage rectifier board. Here is the other little interesting mystery box. See, there's a little RF interface and power adjuster box. And look at that, we got the overload, the attenuation variable from the potentiometer, and we got a plus 15 volt supply voltage. We got two RF inputs, and the RF output goes to the 1 milliwatt input. So in here we got two mixers, and this is where it gets a little bit funny. What are they doing right here? So we got some attenuators, probably also some capacitors, some filters, by bandpath maybe. And then the other one also goes into the other part of that mixer. Really? What are they doing here? I don't understand exactly how they use the mixers or some of the transistors with the variable gain potentiometer. There is actually a few interesting couplings using mixers as many other funky features than just RF mixing, because you can use the diodes in them as variable attenuators or switches and all sorts of funky things. Really, you can also use them for frequency doubling, and they're very interesting parts. And then the milliwatt output goes out there, right? So this is also something I really want to investigate a little bit deeper. What is going on here? So let's try this again with 227 volts of input. If I turn on the fans, they go absolutely crazy. And here is the so-called 400 volts. It's only 309 at that point right there. So this system should now be able to I don't know, control this RF switch. And the fun thing is, let me try and remove this and show you. So here we go with the diode switch. Of course, this is the control voltage. It's positive 308 on that side, and on the other side it is minus 0.9. So that means we have now selected by default this input. Here is the default selected input, and the selection system is probably this one right here. It's 5 volts due to the input right there is low. So I want to try and input a signal into the RCP input and see if this goes high low, and it'll probably switch this whole system and change the positive negative sides of the diode switch. I just turned this off so I could easier explain you the measurements I have just done. So the control input here goes to this system right here and this chip. So there's a potentiometer here where the bias voltage for this field effect transistor is adjusted, and this is also switched either 0 volts or 4.8 volts. Obviously that 4.8 is adjusted right here. It also goes to that chip, and then this high-low signal goes to this system, and it controls, using all those transistors, the two voltages right here that controls the diodes. And one goes very, very positive and one goes a little bit negative. That's of course the diodes isolation or forward current biasing, right? So when this signal path here is selected, then this FET is activated. And when it's not selected, we have the signal going here. This one is disabled to save power. And as you can imagine, the bias for this transistor here is huge. And this is easily copied to the mains input. It goes from 50 to 100 watts of idle current for the whole unit. So here is what I've done. This is my high power output and this is my high power input. This input here is the input that goes directly to the diode switch, all right, and then it goes to the output. So I got a 30 dB through attenuator to a spectrum analyzer with tracking generator input, right? So the tracking generator input, I have normalized these two together to a 0, and that 0 I have moved down 10 dB, like that. So this is my reference line, and when this signal here is selected by this input here, there is a low frequency enable signal going on, right? And this is a 1 megahertz to 1 gigahertz sweep. See, then we have almost no loss, and then we have like 10 to 20 dB loss the first 400, and then the last we have only like 10 dB loss, right? So this is how the RF switch perform. Now I want to see if I can get any gain from the amplifier stage by flipping this one to the other inputs. How about that input here? And I get absolutely nothing. Then I of course crank up the input here and I get nothing. How boring is that? Then I take the other one. We got this overload. So what kind of inputs do I need to give it? I mean, we have this one. It's a 1 milliwatt device, but there's an input attenuator. And also I know about those mixers. They need a little bit of input to drive. And probably we need 2 inputs. So I need to go and pick up another signal generator and plug into the other one. And then the difference between these ones will probably be the one that generates the signal that is amplified, right? Yeah, I disabled the fans. They were driving me nuts. But you can hear there's a lot of stuff going on here, right? Well, I found the bug. So of course this box is probably working. This one is not working because I just got this is of course letting me connect my tracking generator into this unit, and this one should definitely be able to amplify this and give the signal to me, right? So nothing works and I don't get any output signal here as well. And this one tells me this one will there's a little diode detector right there. So there's all this is completely broken. Sadly, I believe it is the pre-driver because I can see this one gets all its bias, and I do see a let me show you. There's a lot of difference in the bias when the enable signal goes on, right? So you see, this is of course with the fans off, but that will be all the watts going on, and that one. So I don't get any input, and it's all because something here is broken. So I can't really do a lot more. That is sad because this one is so cute, super wide band amplifier, and I could have used this for a lot of cool experiments. So I'm actually really sad about this one being broken. And here is how the power meter would have looked if this thing would have worked. I just input a nice sine wave directly into the diode detector right there, just to show the super nice little power meter here is nice and fantastic working. I don't have a lot more to say about this because now we know exactly how broken it is, and that is a little bit sad, and but that is how it is when I get funky free stuff. It just don't work always, and in this case there is just nothing I can do to save it, because I'm not gonna go and buy this little amplifier module for a few €100. It's not going to happen. But definitely this cool thing can be used for all sorts of other experiments. So maybe I will figure out something. Anyway, thank you very much for watching, and I hope to see you so much in another video super soon. Bye bye.